Okay, our purpose for today is to talk about nodal analysis. Now I have to tell you that nodal analysis is probably the single most powerful tool you're ever going to use in circuit analysis, at least in analog circuit analysis. I kind of feel like nodal analysis and Karnaugh maps are kind of the most important tools that we learn in this class. And so I really want to make sure that I give you all the tools you need to succeed with nodal analysis. Now the first step in nodal analysis is to identify the nodes in a circuit, because it's right in the name, nodal analysis. If you don't know what the nodes are, you cannot do nodal analysis. Ultimately, our job is to identify the nodes, then to write equations for each of those nodes, then to solve those equations simultaneously, and then to calculate any other quantities that we might need. Remember that when we first saw our discussion on Kirchhoff's laws, we saw that a node is any point in the circuit where two or more circuit elements connect to each other. I give you kind of a secondary notation about that, and that is to say that a node is really any piece of wire or a connected set of wires where there are no circuit elements mixed in. So you can see here, for example, that I've identified a circuit that has 5 nodes. So here you can see node A is really the full extent of this piece of wire. Node B is the full extent of this piece of wire. Node 2. Node 3 is over here, and it's a very small node, but nonetheless, you get the idea that it is still definitely a piece of wire that is connecting 2 or more circuit elements. In this case, it's just 2. Node number 3 is down here. Node number 3 is connecting together 3 circuit elements. And then node number 5 is right here. So node number 5 is the full extent of this wire. Notice that once you've identified each of the nodes, the only thing that remains is the circuit elements. Now here, the circuit elements are just shown as gray boxes because we don't know whether they're voltage sources or current sources or resistors or even something more advanced that we haven't learned about yet. But we do understand that those gray boxes represent something other than wires, and that nodes only go the full extent of the wires. Once you get to the end of the wires, you've reached the end of the node. So really, that's all there is to identifying nodes, and it might seem a little bit trivial to spend an entire video talking about identifying the nodes and then to have an example on it. But trust me when I tell you that if you can't identify the nodes, then you can't solve a nodal analysis problem. So I would encourage you to take a break, go and solve the identifying nodes in a circuit example. Try to do it yourself first, and then watch the video to double check that you've gotten it correct. Then come back and we're going to talk about the harder step, which is to write the nodal analysis equations.